So this week we are dealing with functions and maybe a little bit more if we're able to squeeze it in the remaining time. Now, a big part about the functions and working with that is to realize that you've already been using functions quite extensively. Every time you've written a line in your code where you said rect or fill or stroke or ellipse, those are functions, and you've been calling them, sometimes passing values, sometimes not, depending on which one it is, and working with it. So this shouldn't necessarily be a big, scary, horrible, oh my gosh, I'm going to freak out, go home, cry in the corner kind of topic. It might be, but hopefully it won't be. Now, what's happening in this document when I look at it is it sets up my document, gets everything all ready, and then it's going to go through and draw my circle on it, and I'll run it here, and it draws it, and a couple things are going on there. Now, when I look at this draw function, it's doing a bunch of different things in one place. And what we want to start getting in the habit of doing is separating lines of code into their own function so that it makes the whole of your program that much more readable. Because when I look at it right now, I have a couple things going on here. Say no stroke, I'm choosing a fill color, I'm drawing a rectangle, so that's my replacing or rewriting the background each frame. Then I'm setting my stroke to white, then I'm updating my speed, then I'm setting my fill based on the speed so that as the ball is moving or changing, my speed is, as the speed's going up or down, then my fill color is going up or down. Then I'm going to draw an ellipse, and I'm drawing my ellipse at my x and y coordinates, and I'm drawing it based on the width of the ball. And then I check to see, hey, has the ball hit the sides? If it has, change the speed, and now I update the speed property. So to think about this, what's really going on is one of the activities is I'm cleaning up the background. One of the activities I'm checking to see has my ball hit the boundaries. One of the activities I'm doing is drawing the ball. So really I have three things happening all inside this one function. And the programming practice that we want to get into is to consolidate appropriate lines of code into a function so that function is doing primarily one activity. Now, to accomplish the activity, that function may need to then call upon other functions to do its job. So currently my draw function is redrawing the background. It's checking to see if the ball has hit the edges, and it's then drawing the ball. So it's doing three things. So what we could do to make this simple sketch a little bit cleaner and a little bit more organized would be to break this out into three separate functions. And in the act of doing this, this is starting to lay the framework so that we can start to organize our code into reusable and understandable chunks. So the same way you were asked to put liberal comments into your programs, if you break it into functions and name your functions in a smart manner, they almost serve the purpose of being good comments, because then it becomes really easy to understand what's going on. So the first one that I'm going to work with is I'm going to now specify my function for redrawing the background. Whoop. And I deleted a line I didn't mean to. Just going to put some extra returns in so it's easier to see. So I'll just make a function. And if you notice, I have what's called the return type on there, and we'll talk about those in a little bit. I have the name of the function, put a couple parentheses after it, then I have my curly braces. Now, when I'm doing this, the name that I call my function is my own. I could have named this anything. It makes sense to name your functions based on what they are doing. You don't want to just make stuff up and call it willy-nilly just because you can. You want to name them in appropriate manners. So now that I've done that, clearing the background. So I will say no stroke, fill, rect. Those are all tied to the cleaning up and clearing out the background. So I can now take those lines of code and I can move them into my clear background function. And then to call upon this, all I have to type is clear background. And now that line of code is going, so line 18 is going to, when that is encountered, it's going to call this function, which will then do no stroke, fill, and rect. Now, in an example like this, where I only had 25 lines of code to begin with, big whoop doing this. But on some of your previous projects you just turned in, people were in the multiple hundreds of lines of code. And if you were organizing your code into functions, and then those functions were doing a particular activity, when we showed it to the class, it would have been so much easier to explain what you were doing, because it's like, oh, at this point, I'm doing this function. At this point, I'm doing that function. And you just call it. And then your draw loop, when we're done, our goal here is to make our draw loop just a set of function calls. And if we do that, our whole program is suddenly going to be much easier to modify, much easier to change, much easier to work with. And we don't have to then change everything all the time, so it will make more sense. So right now, if I run this, I will get the same result as I had before. Now I'm going to create another function. And it will be my checkBoundaries function. So now I can check boundaries. So I can clear the background, check boundaries, and if I run this, I will get the same result. Now, the next chunk of code I have in there is for my ball. So I can just say drawBall, and we'll go and grab the appropriate lines of code there. So now I have three functions. My draw loop, when I look at that, is much easier to understand, because that tells me now draw runs every frame, and draw is going to clear the background, it will check the boundaries, and it will draw the ball. Suddenly, instead of looking at my draw loop going, okay, what's happening every frame in my project, it makes more sense. Check the background, or clear the background, check the boundaries, draw the ball. And we could even subdivide, especially in a more complex project. We might subdivide updating the object, in this case updating the ball, updating its position or other properties, and separate that out from the actual rendering of it. So the actual drawing rendering of the ball would be a separate activity. So we would have an update and we would have a display function for that object. And we will be doing that, needing to do that in some of our more complex projects that we will work on this semester. So my draw loop has now been simplified into simply calling 3 functions. Now each one of these functions is nicely separated from the rest. So now if I wanted to work with my background and have my background filled with a different color or do something else, it'd be really easy because I can see where it is and find the line of code that's doing it, and I don't have to think as hard when I'm looking at my program. We've been working with arguments in our functions since day 1, pretty much. When we drew an ellipse, we drew a rectangle, we were passing arguments to it. When we use the size function, I say size, I'm passing 2 values to it. How big do I want my sketch to be? Smooth has no arguments. So arguments are really, they shouldn't be, like, oh my gosh, what do I do? Or it's just, we've been using them. But arguments, there's a couple of things in this file, the arguments document that you were provided today. The 2 comments in it are really the most important parts about using arguments. When you have an argument, you're passing a value with it. Then the receiving function needs to be then expecting that type or kind of value. So we saw that in someone's homework today with the colors, where it had the int on it with RGB, and we took int off and it broke. It said cannot convert a float to an int because we tried to pass the wrong kind of argument. Another term for arguments is also parameter. So you can create functions and you have parameters with it. And when you define a function, so I defined this function, and I said my parameter is an integer and it's going to be a color value that I'm going to use. Thus I'm getting the cycling colors. And this function is now going to be expecting an integer. So I have to take the value that I pass, and I use floor, but I could have just as readily done int, which then converts what's inside the parentheses to an integer. Run it. You can see it still works. I didn't break it in the process. So my circle, I'm passing an integer to it. It receives the integer, and then it assigns a color value based on using that value. Sets my fill, and then I'm drawing my ellipse using that new fill color. If I pass more than one value, I have to receive that same, or it has to expect to receive that number of values. If my function expects to receive 3 values and I only pass 2, I will get an error message. So if my function expects 3, it needs to get 3, and all 3 need to be of the type that it was expecting. That's one of the issues that need to happen with it, is it needs to get and receive the same kind of thing. So if I wanted to add another value up here, I could. And so I could have just put those up there. Now you'll notice in my function I'm declaring what type of variable, and then I'm setting a name for it. This is like naming any other kind of variable. You get to determine what the name is. You don't have to, there's no predetermined, because you're passing whatever you want to pass to a function. So I've now just modified my function. I'm passing in 3 random numbers that I'll be working with. And now I could just say new x because I have access to that. New x, new y, spaces so it's prettier. So the value here I have access to here. Now if you notice on the color, I created a variable and then assigned that passed parameter to it, and then I used it. That's a very common way of working. And I did it to help kind of clarify what was really going on with it. Because as mentioned earlier today, fewer lines of code is nice because it can sometimes make your code more readable. But too few lines of code and the code is now harder to read because you have to now try and figure out what it is you're doing. X and Y's typically are not, we're kind of able to make sense out of it, but I could now simply here so I've now assigned the three passed in values, and then I use them. So it is considered a common practice that when you pass parameters to a function, then you can assign them to a variable, and then you use that new variable. But this would work just as readily without those three additional variables on lines 14 through 16 if I wanted. I could put it in directly. That's a stylistic choice that if you find your code, you have to think a little bit more about what you're doing, then you probably need to spell it out. If your code makes sense without you having had to do that, then you can just use that passed parameter directly. So we're still getting the same result. Looking at return types, you will notice that I've got a couple variables at the beginning, give them value, got my draw function. My draw function is doing way more than it should. It really should be doing more function calls, and I'm going to be now challenging you to figure out how to do that. And then we will get back to it. And then I have my distance function where it's determining the distance between 2 points. So I'm realizing the name on it shouldn't be distance from point, it should be distance between points would be a more appropriate name. But 11 o'clock at night, apparently my brain wasn't naming functions as well as it should have been last night. So looking at this, we'll watch it run. And there's a few other things in here that we haven't seen yet. I'm actually drawing text in my sketch. We can talk a little bit about that. And I have a center circle, and it's drawing a line from that to wherever the mouse is. And now it's telling me how far away. So if I go kind of in a circle, you'll see that it mostly maintains the same number. So it's telling me how far away I am from it. So approximately 200 that way, 200 that way, because my sketch is 400 tall, so that makes sense. It's 600 wide, so I should see about a 300 and about a 300 there. So and then there's some text. So what's happening is I'm determining my distance by calling the function that I wrote, and then I'm changing a text string, and notice string gets a capital S. Changing the contents of that to update with that distance value. And then I draw a couple rectangles, and then I'm drawing my text message on screen, where using the text function, you put whatever message you want, and then you put where you want it to draw. And it's possible we can actually embed fonts and do all kinds of things like that. And we will look at that in future sessions, just not today. So know that you can do that for you typographic snobs who want your fancy schmancy lettering. So if you want good fonts, you're certainly able and welcome and encouraged to use them. And you can embed any font that makes you happy into your project so that it's now accessible as a data element for your sketch. And we will look at that at a later date. So right now, I'm going to ask you to take this draw function and reorganize this into a set of function calls, because currently it's repainting the background, and then it's drawing the center circle, it's calculating distances, it's drawing my line, it's updating my text, and then all the things that come with drawing for the text. So this, we have fill color and rectangle. All of that is now for the box behind the text, because if you notice there's a little kind of slightly transparent box behind it, so the line goes through the box. You can see it's there, but it doesn't interfere with the text, because I just thought I liked how that looked a little bit better. So organize this into a set of function calls. So the draw function, I want it to only call a set of functions, and then within that, one of those functions will then be updating whatever the distance value is and using that for updating the message. So that's your challenge right now. And then after you've completed that, then we will finish dissecting our distance from point function and explaining that completely. I'm going to start then with clear background. And probably don't need any parameters for that, so I can leave that empty. Then I can go find my background color that was filling it, and then reference it. All right. I could draw other elements. I could draw the little circle in the middle. I could even view this as drawing the circle and drawing the line, because there are things that I'm seeing on screen. I'm going to just leave that as draw other elements. So I have the fill color for the center ellipse. Then we have my distance. Then I set the stroke to 0, black, then draw my line. So those are all kind of, and maybe I want to separate these two elements, the circle and the line, into their own functions. I could, especially as my program gets more complex. They're two pretty basic things, so probably not. And now a third element on here is my I'll draw my information box. Now I can just reference those. So now my draw function is broken into 3 functions: clear background, draw other elements, draw info box. And I have now lost something here. So currently what I've created is broken. But it's very easy to fix. But it's broken for a reason, and I'm okay with that. Well, I'm not okay that it's broken, but I'm okay that I gave you something that needs fixing. One of the important skills that you will get as you go through the class is going to be your troubleshooting ability. Being able to find code when it's broken and figure out how to fix it is probably the most important skill that you can foster and develop. writing code is about 10 to 20% of time spent writing code, and 80 to 90% of your time is spent debugging it and fixing it. That is normal. Even out in industry, the majority of the time is not spent writing the code, it's fixing broken code. Which is why getting comfortable with that, accepting the fact that what you write is not always going to run and will need fixing, is okay. Don't think that you've done something so horrible and wrong. Now, if we go through now, one thing about using Sublime is I don't get nearly as nice of feedback when I have error messages. If I open this in processing, it would be telling me a much more appropriate error message and I could understand it. Now, if I look at the code here, and I'm going to go through it in terms of order of operation. So setup sets the size, smooths it out, and now it sets my initial X and Y to the center of the screen, half of the width and half of the height. Okay, that's good. My draw function will run next, and it's going to call clearBackground. Well, clearBackground just does the background command of 255, so it floods everything with white. Okay, no issues there. drawOtherElements, let's look at that one. drawOtherElements, okay, so it sets the fill color to dark gray, draws my little circle ellipse in the middle, and now it sets variable float D, and then that one it calls a distance based on those X and Y, the center of the screen, and then the current position of the mouse, mouse X, mouse Y. Okay, well that's going to work. And then it sets the stroke color to 0, and then it draws a line between the center of the screen and wherever the mouse is. All right. So drawOtherElements is probably not breaking. drawInfoBox, well, let's find out. So currently, and this is something that now that my code is in functions, what I can do is I can now just comment out the guts of a function. And sometimes you have to comment out something line by line to find where the error is. But if I comment out that function and run this, let's see what happens. Hey, look, it's working. So that tells me my first two functions that I'm calling, clearBackground and drawOtherElements, are working because I commented out drawInfoBox, okay, and that worked. All right. So now, if I were to uncomment a number of things and run it, let's see what happens. Oh, still working. Get my gray box now, still working. So that's telling me that my error in my project is either going to be with line 31 or line 36 because one of these two is my error. Now if I look up here, we can see string has been defined as a global variable. So if I uncomment line 36 and run it, okay, it got a little grumpy there. Not the same message as last time, but it got a little grumpy. Now if we look at this, message has no value, yet we're telling it to write that text at that location. So, you know, maybe, I mean, if we just looked and said, if we gave it some value, let's see. And this is part of the troubleshooting process. Oh, look it. See, now I have text showing up. It says hi. It's always nice to make your messages, you know, polite and friendly, because when your code is broken, if you send, you know, I hate the world and everything's evil and bad and all, and you use negativity, that doesn't help your mood when your code stays broken. So I actually believe that if you send yourself happy messages and nice messages or even affirming messages, that can be useful, because when it's happening while your code is broken, you're not in a good mood anyway. So you don't need to reinforce that by telling yourself bad things. So that tells me clearly the error is in line 31. So if I look at my line 31, message is equal to distance plus D. But if I look at where D has been defined, I will notice D is being defined in drawOtherElements. I'm going to just separate that out a little bit more so it stands out. Float D. So I'm defining a variable inside a function. When you do that, that variable lives only inside that function, making drawInfoBox incapable of even knowing that something even exists called D. Because float D was defined here, drawInfoBox doesn't know about it. But what you can do if you define D outside of the function, now drawOtherElements has access to it, and drawInfoBox will have access to it. So because both functions want access to D, we need to define it outside of a function. So any variable defined in a function lives in that function. So it's kind of like whatever people do in Las Vegas is defined by what happens in Las Vegas. So it stays in Vegas. It doesn't come home with them, generally. And now we can see I'm getting my distance value. No error messages. And it's working. Let's get rid of the extra lines now. Thing that needs pointing out. So I'm taking my past arguments or parameters. I'm using those. And then I'm creating this new value. And then this new value, when it's all done, I have this one last line in here called return. Now, if you notice, this function that I wrote here, distance from point, does not start out with the word void. It starts out with the word float. Because I am returning a number with this. So this function, see, drawInfoBox, it just runs. And it says void. There's no return statement in there. It's not giving you anything back. It's not helping you out. But this function, when it's all done, I'm returning this value. So whoever calls on this function gets back information. So if we look at our other functions like rect doesn't return anything. It just draws a box at that coordinates of that width and height. It's not giving me anything back. But here, when I call distance from point and give it my x1, y1, x2, y2 values, it gives me back a number. It gives me back this number right here. It returns dis. So when a function returns a value, we list the value type at the beginning. So when a function returns nothing, we put void. When a function gives us something, we tell the program, what am I getting back? A float, a string, an object. We will be using functions that actually return objects as part of it, which is even very cool at that point, because we can do all kinds of voodoo magic on our computers with it. So we have functions where we just pass arguments in, and functions that do nothing in terms of returning a value. They just do. Functions that return a value are more often viewed as a utility function. So we use them when we are processing a string of characters to say, hey, look for this group of characters or this type of character or this word within a phrase. So we can search a string of characters and say, go find this word, see if it's in there. And if so, return that string. We can return math, which is probably one of the most common things that functions do, is they return a math value to us. So we will write We could write a add numbers function, and then it could take 3, 4, 5 numbers. Then we pass those numbers in, it adds them up, and it returns whatever their sum is. So you can have all of these complex functions, and it's not uncommon in languages that don't have a lot of pre-built utility functions, or you may decide that you don't like how their functions work. So the way that the random function works in processing, where we just say random, put in a number, and it gives me 0 to that number as a range of results, that's great. Every other language, if I want a random number, I say random, and then I have to times it by that range I want. And if I don't want it to be 0 to something, say I want a range of numbers between 5 and 10, well, then I have to take and say add 15 minus 5, and then that gives me a range between 5 and 10. And, well, that's stupid. I should be able to just say random 5, 10, and I get random numbers between 5 and 10. So a common thing that people do when they do a lot of projects in a particular programming language is they write utility functions to do what they need to do, and then they just reuse those from project to project. So this distance from point, which is probably better renamed as distance between points, now that I have that written, I could copy paste that into every project I work on and use it, or I could even work on turning it into a library that I could just import. And if I have a whole host of dozens of utility functions for doing things that aren't hard baked into the language, I can speed up my workflow. And that's a very common programming practice.